If x is squared, it's either opening up or down, and you can tell the direction by what? The sign of the coefficient of x squared. This parabola opens up. What about this one? In this one, y is being squared, so it's either opening left or right, and since this is positive, it's opening to the right. Okay? All right, those are just basic things. Circles. These are two examples of circles. When you have a circle, both your x and your y is being squared. This is the standard form of the equation of a circle. If you recall, we took just equations and put them into standard form using, what was it? Completing the square. Okay, you won't have to do that. But you do need to recognize that this is a circle. You do need to recognize how to find the center and the radius of this circle. Does anybody remember? Okay, well, these are two different circles, but let's start with this first one. This first one up here. How do you find the center? Whatever's being subtracted from x and y. If there's nothing, then the center for this first one is 0, 0, and the radius is 5. It's the square root of that number over there. The radius was 5, okay, for that first equation. For the second equation, what's the center? 1, negative 2. Remember, that's that kooky rule about taking the opposite sign. It applied with parabolas, circles, hyperbolas, and ellipses. All right, 1, negative 2, and the radius was equal to 6. All right, so you need to recognize it's a circle and how to find its center and its radius. Go. We had ellipses. Let me adjust this some. Okay, who remembers what an ellipse is? It's an oval, or it looks like an oval, okay? It's like a squished circle, but there are specific characteristics about it. It has a major and a minor axis. Does anybody remember how to tell which one was the major or the minor axis? The first one, okay? If the thing is written in the right order, your bigger number is going to be in the denominator first. So that means your first one is your major axis. All right, which means the first equation opens, not opens, but is long this way along the x-axis. And the second equation looks something like this. Now, we also had being able to find the center and the length of the major or the minor axis. Does anybody remember? The center is found the same way as the center of the circle. Whatever's being subtracted from x or y. Okay? So here in this first one, our center would be at 0, 0. Our major axis would be 5. And our minor axis would be 4. And when I say it's 5 and 4, it means from the center, you're going 5 units for the major axis in both directions, and you're going 4 units for the minor axis in both directions. Okay? You won't have to graph it, but I do want you to know how to find that. In the second one, what's the center? 1, 0. Whatever's being subtracted from x is the x coordinate. Whatever's being subtracted from y is the y coordinate. Okay, that doesn't change. Now, Your major axis this time is following your y-axis, and how far do you move from the center? 6 units. And your minor axis, how far do you move from the center? 5 units.
Why is it not -1?
Because that's that kooky rule, like in the parabolas and the circles and everything else. The equation calls for subtracting the coordinate. So if you are subtracting something from x, and it's still a minus sign, it means you subtracted a positive number. If it's a plus sign, it means you subtracted a negative number.
Are we going to be graphing these?
No. You're not going to have to graph. And then finally, a hyperbola. If you remember, the equation looked exactly like an ellipse, except for it's a minus sign. And the rules, like the ellipse, about how to find the center and how to find which axis is the major and which one's the minor, are exactly the same. The center of this hyperbola is where? 0, 0. Our major axis, or the distance from the center to the edge of our major axis, is what? 5. The square root of this first denominator. Yes, ma'am.
The major axis is going to be the first one.
Just like in the ellipse. So this one opens to the left and the right. Okay? And our minor axis, if you recall when we did hyperbolas, we didn't really worry about it, but we do know that it's a distance of 3 from the center. This hyperbola would be opening this way. Remember, it's like an ellipse that you cut in half and flipped. Flipped out. Okay? What is this?
Hyperbola.
It's a hyperbola. Where's the center? Is your major axis the x or the y-axis? The y-axis. And the distance from the center to the edge of that is 7. And the distance from the center to the edge of your minor is 2. The graph of this would be going in this direction, because now y is your major axis. All right, not ready for that yet. Okay. I just saw it open, huh? Oh, it's there. I just get to the beginning. Let's go back over everything we've talked about. Don't write anything down. I want you to think. We've already written all this stuff down. Boy, we wrote a lot down. Okay. Anything to the 0 power equals 1. 0 power, it's equal to 1. Remember, the parentheses are very important. Tells you what's being raised to the 0 power and if the negative is included in that or not. Negative exponents mean flip. Take the inverse of this thing. Wherever it is, if it's got a negative exponent, you flip it, and then what do you do with the negative?
Is all this on the
I'm recording it right now. But the rest of it is already on there. Okay? What do you do with the negative?